Welcome to Kenton Teaches. Enjoy the video.
Quantum chips use qubits that encode information in quantum states like superposition and entanglement. Engineers cool chips to around 10 millikelvin to reduce thermal noise. The device sits inside a dilution refrigerator that stages temperatures from 4 Kelvin down to 10 millikelvin. Qubit hardware uses superconducting circuits made of aluminum or niobium thin films. Control lines deliver microwave pulses at gigahertz frequencies to drive quantum gates with precise timing. Quantum gates manipulate qubit states using calibrated microwave or flux pulses delivered through control lines. A single qubit gate typically lasts 10 to 50 nanoseconds, depending on hardware parameters. 2-qubit gates entangle pairs and usually take 40 to 200 nanoseconds per operation. Gate fidelity depends on calibration, with error rates ranging from 0.1% to a few percent today. Quantum circuits are compiled into pulse sequences by control electronics before running on the chip. Decoherence limits how long qubits retain quantum information, measured by T1 and T2 coherence times. Typical superconducting qubits show T1 or T2 from 20 microseconds to 200 microseconds today. Readout uses dispersive measurement with resonators and takes 100 to 500 nanoseconds per shot with amplifiers. Error correction encodes logical qubits across many physical qubits, often requiring hundreds of physical qubits per logical qubit. Scaling requires
Thanks for watching. Please subscribe if this video was helpful.